Welcome to my new calculus channel. My name is John Gabriel, and today I'm going to talk with you about antenaresis. I don't know if you've heard this term here. It's this word down here, and also the division algorithm and the greatest common denominator or factor. So let's begin. So you may have, excuse me, have heard many different things about the division algorithm, and typically you'll see a statement like this by highly ignorant mainstream academics. Given any integer d is greater than 0, and any integer a is greater than 0, there exist unique integers, blah, 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 such that this is true. Well, of course, this little identity here has its origins in Euclid's Elements in Book 7 and Proposition 1 and 2. Just to cut a long story short, that's not the division algorithm. Division is used in this algorithm, but that is not what is called the division algorithm. Most mathematics professors do not understand basic arithmetic or even the concept of number, and have never understood number theory. That's why you have all this rot of set theory and propositional logic and first order logic, etc. But anyway, I'm not going to go into that because that's a waste of time. Now, I've never heard of the word antenaresis, by the way, and I'm a Greek. The word that is used in Euclid's Elements is this word here, antenaresis, and it means a repeated subtraction or repeated difference. So I have no clue what is the origin of the word antenaresis and where it comes from, but I've seen it tossed around many times even since I was young, and it simply, according to those who use it, means repeated subtraction. So anyway, that's a little minor point. But now, what is division exactly? Well, we'll come to see what it is in a short while. But what I want to say is that this statement here is not generally true. A and D don't have to be integers. And it's a very bad way to teach people by saying there exist unique integers, because that doesn't explain, excuse me, what this means. And it doesn't explain the process behind finding the greatest common denominator. So for example, over here I'll show you how you can choose numbers in here that are actually not integers. So as you can see here, this is pi divided by root 2. Those are not numbers. In fact, those are symbols for incommensurable magnitudes. So this particular theorem or algorithm, it's a myth that it only works on integers, because from Euclid's book we can see that he uses line segments. And yes, Euclid did use the word number. For example, here he says δύο αριθμών ανίσων κειμένων, and then the word that I showed you earlier on, antiferumenου, it says that these here are magnitudes and not necessarily numbers, okay? So that's the first myth, that the algorithm works only on integers. And the second myth is that it defines the division operation. It doesn't. The division operation is used in the algorithm, but the actual division algorithm is entirely different. And what I'll do is I'll provide a link to this article, which is only 5 pages long, in the details section of the YouTube, and you can read it to see how all these things work. Well, it would help, first of all, if the orangutans in mainstream academia actually understood what a number means, what is a fraction, what do the different parts mean, instead of just learning things off rote fashion and not understanding what a fraction actually means, and that all numbers are fractions, and that there is no such thing as an irrational number or a real number. That's just garbage. So what do we actually do when we divide? We actually perform measurement. So if we wanted to divide this line segment by this one, there are two ways to do it. We could see how many of these shorter ones we can fit into the bigger one and parts of it, or we could start off by subtracting it and counting out how many times we subtracted it. And so I show you that by using the long division algorithm on a proper fraction, such as 1/3, what is a proper fraction? It means a number in which the numerator is less than the denominator. All numbers are fractions, by the way, even whole numbers and integers, they're all fractions. So I show you in this article how you can actually find the division algorithm in terms of the original concepts of Euclid, and also how to find the greatest common denominator. But it is useful to note that division is a finite process of repeated subtraction with a stopping condition when the remainder is less than the divisor, okay, as I demonstrate in this example here. Although we're using a process of division in this algorithm, we're not really dividing 1 by 3 indefinitely, okay? There's no such thing. Infinity is a junk concept. It's all nonsense. So this particular identity here gives rise to another identity called Zoats Identity. I don't even know what is remarkable about Zoat, because it is derived directly from Euclid's algorithm, and it really doesn't say anything remarkable or anything that, even in my opinion, needs to be proved. And so here I'll also give you an example of how to find the greatest common denominator of 270 and 192. It's very simple. If I were you, I would read it to understand it. What we're trying to do is find the greatest number that will measure both these two numbers. And of course, I explain here that whatever measures the remainder, the divisor will also measure the number a. And so we continue to find new quotients and remainders until a factor is found, or we determine that a and q are relatively prime to each other. So it is a shame that modern mainstream academics are so incompetent. And there is a lot more that I could talk about here, but I'd encourage you to look at this document that I'll put in the details section, and also to download the most important mathematics book ever written, which has a link to it here, and also to read How We Got Numbers on LinkedIn. So that's this short little presentation on antenaresis, which really means repeated subtraction according to the mainstream, but I don't know where that word came from, and I can't find any source to it. So there you have it. This is a new calculus channel. My name is John Gabriel. Until next time, goodbye.